Hi, my name is Michael Lekan-Kehinde. This research focuses on analysis of the impact of acoustic performance on students with autism spectrum disorder. So in this research, we'll be looking at the research focus and overview. We're looking at the research background. We're looking at the research statement, research methodology, and the research methodology. Under that, we have about 4 sections where we discuss the research timeline, where we discuss the expert interview, the literature review, and also the analysis and recommendation. And then we jump into the conclusion from there. 30% of the population is currently considered neurodiverse. Neurodiversity was the initial coined term to describe autism spectrum disorder, although this has been expanded currently to include HDAD and other disorders as well. And what is autism spectrum disorder? Is a neurodevelopmental condition which could be complex, multifactorial, and pervasive, but describes people with a different brain process. Acoustics in learning spaces as well is very important, and because learning spaces prepare for adult life, functioning, and impactful living, and acoustics is a big component of the learning space in terms of learning, concentration, motivation, behavior, and even performance. Research background. Um, Good acoustic performance has been identified as one of the critical indoor environmental quality factors or criteria for student learning and development. And um, Ackley et al. 2017 mentioned that childhood is the time in which children develop lifelong skills. So it's therefore important to put a lot of effort into ensuring that the learning environment is conducive. And then it talks about the importance of acoustic performance. And from a research by the National Research Institute, it was found out that acoustic performance helps in language acquisition, concentration, information retention, and general comfort within the environment. So there's importance to ensure that communication between students and students, um, educators or teachers and students, and even parents and students within the learning environment is conducive. And there have been several guidelines used to improve the acoustical suitability of the classroom for neurodiverse students, but little or limited research on the stability of this guideline to students with has been identified for the stability of this guideline to students with autism spectrum disorder. So this research tends to look towards that. This research looks at the NSI guideline, focusing on the standard for spaces with good acoustical quality and gleans from the advice of experts through interviews on the suitability to students with autism spectrum disorder. The research seeks to answer 2 questions. Is the acoustical guideline for designing K-12 learning spaces suitable for students with autism? And secondly, what performance threshold and material recommendation would ensure an improvement of the stability to students with autism? And the information was analyzed into teams, and then the insight from literature reviews and the NSI guideline was used to establish some baseline. Research timeline. The research timeline you said in November and ended around April to be precise. And it started with the review of design constitution for learning spaces in November, review of acoustical guideline, review of suitability matrix criteria for learning spaces. And between November and January, there was interviews of acousticians, there was interview of audiologists, interview with interior designers who was working in the new device space. And then between January and April, there was analysis through user testing, development of teams, discussion to establish some of these research, and also recommendations were made. And so the qualitative analysis was the method used, and we start with logical research and argumentation, and then move on to expert interviews. So first of all was the logical research and argumentation, where logical blocks were established. What is the cause of acoustical difficulty for students with autism, ASD? What is the acoustical need of students with ASD in the learning environment? Are the acoustic needs of neurotypical students similar to that of neurodiverse students? Establishing study categories, guideline standards, perceived stability matrix. And then the next thing was the expert interview, where these questions were explored. What are the design considerations before designing learning spaces relating it to logical blocks? The logical blocks created already. What are the design considerations after designing, doing construction and finishing relating to logical blocks? What is the understanding of the experience of students with ASD within the building, and how can the learning spaces be improved? Giving a glimpse into the logical blocks that was created, first was acoustics in classroom. The logical blocks, what factors were important? Though there are other factors that were important, but what these were three major factors that were really considered, which was the revision time measured in seconds, the frequency measured in hertz, and the sound level measured in decibel. Also, other factors like the vibration and other factors, especially in different environments, was also considered. But these were the three major considered for these research. For autism, we looked at two different types of logical blocks, and we looked at it at one, that is the hypersensitive um, students, and also the hypersensitive. Hypersensitive are students who react to stimuli, who have a high reaction to stimuli, while hypersensitive are less observant or less reactive to stimuli. And then we are also looked at the functional levels of autism, and we looked at level 1, which requires support, level 2 requires increased support, and level 3 requires very substantial support. Then we look at the baseline for acoustical guidelines, and then we look at small space, and we look at the measurement of small space looking at less than 10,000 feet cube, and we looked at also the medium space, and we looked at the large space, identifying the background noise, the occupied sound level, and the variation time for each of these space. Then the methodology was then to interview four acousticians. Um, we interviewed, and then audiologists and auditory experts, one each, and the lighting designer was interviewed. And we asked several questions boiling around understanding the acoustical design consideration for learning spaces, clarifying the acoustical challenge that might be faced by students with autism, and how to improve those spaces as well. The next phase was to analyze using user testing. So after this, the interview and notes was recorded and then was taken into user testing, where a first level analysis was taken, and the codes were developed and then grouped into codes using user testing, and then the main codes were then created out of it, and then they were redefined to create the final teams. And the teams include team 1, the individuality of autism spectrum disorder and the impact of learning spaces on students with ASD. 2, team 2, the need for improvement of current acoustical and design guidelines for suitability to students with ASD. 3, current solution and their limitations. 4, recommendation for creating inclusive learning spaces, including sound, design, material, and general consideration. And 5 was the limitation, further study, and further research that might be required in this area. So I'll discuss about the methodology with the analysis and teams, and I'm going to talk about each team independently and what were the some of the big points from the teams. The team 1, individuality of autism spectrum disorder and the impact of learning spaces on students with ASD. First, one of the major factor that was identified that ASD are vastly different, despite the fact that there are categories. There was an individuality of ASD, so it's very important to understand that each ASD student or student with ASD are very vastly different. Um, 2, concentration loss leads to long-term disengagement, so as it takes time for them to process or to come back from confusion or from distractions. So it's important to know that once um, students with ASD lose concentration, it's very difficult for them to bring back themselves to listening or to concentrating. 3, learning impacts class productivity and job placement. There's a long-term effect of um, of learning impediment that might occur due to sound challenges. 4, the lack of just placement leads to dependency. So in the long run, this lack of leads to dependency and the insufficiency of autism spectrum disorder students to solve their own problems. And then team 2 was the need for improvement of current acoustical guidelines and design guidelines for stability to students with ASD. And first, one of the major points was students with ASD have difficulty processing speech information and multisensory stimuli. So one of the identification was the fact that multisensory stimuli are very difficult to process for students with ASD. And noise is actually very irritant to students with ASD. It is very distracting. Um, Also, each student with ASD responds to noise and stimuli differently, and also to identify that speech is a complex stimuli. So speech is complex. And then some of these experts also identify some current guidelines that are suitable to spaces, and current guidelines suggest 0.6 to 0.7 RT, especially sites with ambient ceiling and 11 feet height to ceiling. These are some of the what the current guidelines identifies. Team 3 focused on the current solution and their limitation. And some of the solutions that were identified was voice amplification, use of headphones, noise masking, okay, some other adequate strategies like therapy as well, induction loop system. But there were limitations to these solutions, especially it was not it was stable for only limited categories of ASD. So e.g. Application for hypersensitive students. So hypersensitive application is only needed for hypersensitive because for hypersensitive students, even the noise currently was they were very reactive to it, so they needed it to be reduced. So there is need for a more encompassing solution that covers students with autism spectrum disorder, not just a section of them. So the also solutions were not encouraging inclusivity. That was another identification with a limitation. Solutions didn't encourage social interactions or could lead to misunderstanding of interest and communication. For example, having an headphone on might lead to students feeling that a particular student is not interested in communicating or participating in peer discussions, whereas it's just a means of reducing the noise impact in the current environment. Also, the solutions require a lot of adaptability, that's adaptability or modification mechanism for stability. It requires a lot of changes to the environment. That means it's not encompassing with the learning space itself. And then team 4 was the recommendation for creating inclusive learning spaces, looking at sound, design, material, and general consideration. And I start with design. So the recommendation around smaller environments, natural lighting, creating smaller concept spaces in large spaces such as gyms and criteria that will accommodate students with ASD. Also looking at sound, total elimination of background noise, reduction of the impact of intermittent noise and reverberation. So there is need for understanding of what level of reverberation is needed in the class space, what level of intermittent noise is needed in the class space as well. Also, material and specification. Use of less noisy mechanical, electrical, and lighting system, including wash hand basin and water closet. Using sensors-based facility or designing sensors-based fixtures to reduce unexpected sound. So this were very important. Also, general teacher educator understanding of space and utilization. So there's need for a bit of more understanding of how to speak to ensure that the classroom is well that leads to concentration or is well communicated, like speaking in the classroom is well communicated as well. Research limitation and further and feature research. So one of the major limitations was the understanding of tonal effect on student productivity. This could be more annoying than other sounds. Also, hearing threshold of ASD, there's lack of data into the hearing acuity curve of students with ASD. Also, use of ANI guidelines, simple number reference, multisensory processing in autism, and further research is looking at material tonality and frequency, noise reduction frequency, hearing curve acuity, materials, and also adoption qualities in species. I acknowledge all those mentioned or identified here as well for their help doing this research. And conclusion, so I believe this research is a journey and requires the participation of all stakeholders and non-stakeholders to ensure inclusivity for all. Findings from this research recommends the removal of or reduction of background noise, intermittent sound, or sensors-based fixtures. There is need for reimagined design, materials, and sound considerations to meet the needs of students with ASD. There's also need for an increased need for further advisory and training of parents, educators, and caregivers, even students and the community on how to accommodate students with ASD. And lastly, there is need for an increased need for more inclusivity of stakeholders, researchers, and designers in developing more suitable recommendation and guidelines for students with ASD. And I want to say these are my sources. Thank you. Thank you so much.